can start now.
So a very good morning to Dr. Wani, and today we are from Group 7 and we are going to present our own group group presentation about how we conduct our own experiment. And okay, I will share my screen. Wait. Share content. Share screen. And here. Can you guys hear?
No.
Okay, no, okay. So I'm going to say it myself like how I did for the moment lab. Okay. So hi everyone, I'm Audrey, and this is my part 1 experiment. I use water soluble vitamin with 200 ml of water because it's water soluble, so I need water. Baby wipes, which I call wet tissue, vanilla extract, glue, and hand sanitizer. So I'm going to use the pH indicator to determine the pH value of each of the household chemical that I got in my house. So for the pH value of water-soluble vitamin, it's pH 5 for mine. Yeah, because it's acidic, so it's below than pH 7. So for the second one, I'm going to use the wet tissue, which I call it a baby wipe. Since wet tissue is wet, so I can just directly wipe it on the pH indicator. And I'm going to compare it with the pH code. So it's also pH 5 for my wet tissue. So the third one is vanilla extract. I'm going to dip it and wipe it with a clean, dry tissue. So the color changes. So I compare it again with the color to indicate the pH value. It's pH 5 also. So I get many pH 5 actually. So the glue I have poured it in a plastic spoon before I start my experiment, and I use same thing. I use the pH indicator to dip in and dry it with a wet tissue. No, a dry tissue paper. It's the different tissue paper actually. So the pH it's pH 7. Oh, because initially I haven't wait enough time. So initially the pH was pH 5, but it turns out pH 7 after some time. So lastly, it's the hand sanitizer. And it's my last pH indicator. So I'm going to use my last pH indicator. And I actually expect for a basic result, which is above pH 7. But it turns out, yeah, I dry it for very, very long because I don't really believe the result of it. But I can't change the result. So it's pH 7 also. So I don't know why it's pH 7 because hand sanitizer, it's 99.99 alcohol, alcohol. So this is my result. Yeah, thank you for watching. So yeah, that's all for my. Can you guys hear me? Wait. Okay. Can you guys hear me? Oh, so just now my presentation was clear. Okay.
Yes.
Okay. Let's proceed with our next group member, which is Hafi. So Hafi, can you share your screen?
Can you guys see the video?
Yes.
Yes.
Yeah.
Okay. Okay, firstly, I use the hair gel. So this is the hair gel. So I dip it, and eventually I get the value of, after I compare it, it says that pH 7. Yes. So for the second, I use shampoo, which after I dip it, I get the value of 2, pH 2. Shampoo pH 2. And after that, I use the toothpaste. Here, here is toothpaste. And the value of toothpaste is 11, pH 11. Okay. So then I use the vinegar, I don't know, vinegar, cuka. And the pH value is 1. So I only get 4 because the last indicator I use the artificial coloring extract, but it turns out that the indicator turns yellow, so I cannot. The indicator like this. Turns out like this. Yeah. So that's all. Vinegar 1, toothpaste 11, shampoo 2, hair gel 7. That's all. Is it clear?
Yes.
Yeah, clear.
Okay. I'm
But
sorry.
shampoo too.
Yeah.
Yeah, it's very weird. Like just like my hand sanitizer, I know.
Yeah. Supposed to
So
be.
okay, next. Saunders, are you ready to present?
Yes. 1 minute. Let me.
Yeah, okay, we will wait for you. We will wait. Yeah, just you can take your time.
Take your time. Okay.
But yeah, I also don't know why my hand sanitizer would be 7, because it's like 99.99 alcohol, and I really wait for a long time to dry, you know. Like I dry it for a long time, and it's still pH 7. I'm like, should I just wait it for a little while? So I trimmed the video a little bit because I waited for a very long time. So I'm actually quite disappointed with my own result because O was pH 5 and pH 7 only, and it doesn't show good enough for the result. But Happy's one actually okay. Are you ready, Sandos? Okay.
Can you see my screen? Okay. So yeah. Okay, so I tried. Wait. So those are the materials. I use Clorox, Coca-Cola, rose water, floor cleaner, and face cleanser. So for the first one, Coca-Cola. Okay, it's taking too long. pH of 2. And then I use the floor cleaner. As you can see, pH 7, 6, 7. I guess this is pH 7. Yes, pH 7. And then I use rose water. Rose water, pH of 5. Oh, sorry for this. And then I use face cleanser. Which is also pH 6. And then lastly, Clorox, the only alkaline material, gives pH of 13. And yeah, that's all. That's all.
Okay, Sandos. May I double confirm with you that your cola was pH 2? Are you sure?
Yes, I also searched on Google.
Oh, so cola. Oh, so cola is actually acidic.
Yeah, I also was confused, but then I found out it's also pH of 2.
Oh, okay. I'm so glad that I learned new thing that it's the first time I know that cola was acidic. Yeah. And your floor cleaner was pH 7.
6.
Floor cleaner.
Oh yeah, sorry, 7. Yeah,
Okay.
which is neutral.
And one more, I want to ask, what water was that?
Rose water. I don't know if you guys know this, but we use it sometimes to flavor food.
To flavor food.
Yes.
It is something to for it. Can we drink the drink?
No, it's not a drink. It's
not a drink. Okay.
used for cooking.
Okay. So Kelly, are you ready for your presentation?
Yeah, can you guys see my screen?
Yes.
Yeah.
So this is my video lah. Yeah. Okay, so this is the part 1 of my video. The ingredient I have is detergent, soy sauce, insecticide, perfume, and muscular edge lah. So I just open it and pour it on different container to avoid contamination. Okay. Then I label it with label to prevent me from mixing it up. So I label it. Okay. So for detergent part, I dip the universal indicator inside the detergent. Yeah, then wait until it dry. For soy sauce, I also repeat the process. I dip the universal indicator in the soy sauce. Same now the process, insecticide also. I dip it differently. For perfume, this is the perfume part. The perfume is green color one, yeah. Okay. So finally, it's the muscular edge lah, which is the yoko. I dip it in the yoko also. Then I refer those universal indicator for the pH list lah. So this is for the detergent one. I refer it one by one. Then I come out with this result. So I come up with, if you refer to the pH list just now, I come up with the result detergent is pH 8 to 9. I'm not sure. I think it's between pH 8 or 9. So it's like maybe 8.2, 8.3. But the soy sauce I came up with pH 4, I think. For me, I think it's not very accurate because as we know, soy sauce has some stain. So the stain maybe affect my results a bit. So I'm not so sure about soy sauce is pH 4 or not. Then for insecticide, perfume, and muscular issues, after I compare with the pH list, I found that it's pH 5 to 6 lah. So that's the presentation for me. Are you guys clear? Is it clear? How to stop? Okay.
Yeah.
So any question about my results or presentation?
May I ask if you did dry the pH indicator before you compare?
Yeah, sure. I
Or you
did.
did dry? Yeah,
Yeah.
with tissue. Okay. Okay. I don't think a
I
question.
Then
But
what is tissue paper?
so, what do you guys think we should use the result? Because as you guys know, for my result, it's not that good because we are doctor said that we can use one of our groupmate result, but the lab report we should do it individually, right? So I'm planning to, because like mine and Hafiz one actually quite good besides the shampoo. Yeah. So good job. And Kelly's one, she's not so sure about the detergent.
The soy sauce.
And yeah, the soy sauce. Yeah. Actually, we can use Sondo's one.
But I think
But
we can pick from different how to say?
Yep.
Maybe I take for example, I take the
Yes, I get
from Audrey, then take the Coca-Cola from Sondos, like everyone take one, we include in our report. Is it better?
Good idea. So at the end of this video, we should conclude to doctor that whose result we use and what pH like that and what chemical, household chemical. Yeah, it's a good idea. So before the experiment, we know about the more acidic it is, the lower the pH it is. So we do expect this kind of result, but some of our results don't really turns out well. For example, my hand sanitizer, it turns out neutral, and actually that's one limitation, and we will discuss this limitation on our part 3 later in our discussion. So for our part 1 experiment, it's done. We are proceeding with our part 2. Do you all agree? Or do you have any question in part 1? No. So we can proceed with our part 2 experiment, which is the multimeter for the fruits and vegetable one. Okay, so I'm going to share my screen. And this is my part 2 experiment. So wait, I'm going to mute. Okay, can you guys hear me?
Yeah.
Can you guys see my screen?
Yes.
Okay. So this is my part 2 experiment where I use fruits and vegetables. I use lemon, tomato, and apple. Oh, I'm sorry because this is my first time editing video, so it may looks a bit bad. Yeah. So this is how I conduct my experiment. So I started with lemon first, and the lemon reading was 31.9. For the second reading, I wait until the reading is stable, so it takes some time. So my second reading is 27.4. It's actually quite a gap, but later I will take the average of it in our lab report if we use this. So the third reading of the lemon is 26.2. So this part is actually me checking it out for one more time, but I turned out exchange. So now I'm going to take off this. Yeah, I took off the screw and rinse it with distilled water. Actually, it's just normal water. I am not confirmed if it's distilled or not. And this is my tomato. I replace it with tomato. Like I put the screw back into the tomato. So first reading of tomato, it's 3.4. And this is my second reading. It's second reading of tomato, it's 2.7. And my third reading of tomato, it's 2.4. So now again, I take out the screw and rinse it with distilled water again. And I put it inside the apple. So my first reading for the apple, it's 15. It's 15 sharp. It's 15.0. Second reading for the apple, it's 15.2. I took some time because I jot the result into the paper. So this is my third reading. My third reading, oh, it's a bit not stable, the reading. So I wait until the reading becomes stable and I took the stable reading. So my third reading, it's for the apple, it's 15.2. So that's all for my experiment. Actually, I did the experiment just now. Okay. Wait. Okay. Is my presentation clear?
Okay, so I have a question. The value measured is current or resistance?
Oh, I measure the resistance, like just like the video, doctor's video. I do exactly as doctor's one. So I took it's the resistance. Yeah.
Okay, okay.
Any questions, or if there's no question, any question for me? Like, do you have any not like anything that you don't understand from my experiment?
All good.
Okay. Okay, then we should proceed with Hafi. Hafi, are you ready?
Yes.
Okay.
For the first fruit, I use cucumber. In this video, I take only one reading because I didn't apa, tak perasan lah. I didn't expect to take the three reading, and then I did the second and third reading. Yeah, but I didn't record it. So yeah. So this is cucumber. So for the first reading, I get 5.5. And for the second reading, I get 5.7. For the third reading, I get 5.4, which is quite near. And for the second fruit, I use pomegranate. So I wash the nail and the screw and stick it. Okay. I wait till the reading is stable. Right. Yeah. So the reading is 0.03. Second reading is 0.05. For the third reading 0.03 also. So yeah. For the for the third one, I use sour mango. Yeah, mango but it's sour. The green one. Uh, mm, for the first reading, I get 0.09. Okay. Second reading, I get 0.08. And for the third reading, I get 0.09 also. So that's it. Is it clear?
Yes, yes, yes. It's clear. So double confirm. I'm just double confirm. Your cucumber is like 5 point something.
Yeah.
You're using the current, right?
I think, yeah, wait there.
Okay.
Yes.
And
Yes.
for your pomegranate, you get 0.0 something.
Yes. Because it is acidic.
Okay. This we should discuss in discussion later. So Saunders, are you ready?
Yes. Hold on.
Okay. Take your time.
Can you see my screen?
Haven't yet.
Um,
Kelly, are you talking? Cause you're mute. You mute your mic. Okay, okay. I thought you're talking cause yeah. I'm sorry. Good job, Happy. You know, actually, I did both current and resistant, but I don't know which one should I choose. And it's because doctor in doctor's video, it's at the resistant there. So I just present my resistance. Yeah.
Kelly, you can present first. My laptop is lagging.
Uh, it's okay. It is very light. No, is it very light? Yeah.
Yeah, wait. Um. hmm.
Sundos, may I ask what you use for the part 2 experiment? You use strawberry.
Part 2, I use strawberry, lemon, and tomato.
Okay. It's lime, not lemon.
Oh yeah.
Yeah.
My God, I'm so sorry.
It's okay.
I'm so much sorry.
So Nurse, is it very lag? Because if
Yeah.
it is very lag, then we will proceed to Kelly first. Kelly, are you
Yeah.
okay? Okay.
Okay.
Okay, so I share my screen lah. Yeah. Okay. You guys can saw my screen, right?
Yeah.
I'm not sure. Okay. Okay, so can you guys listen the audio? Like the volume of this experiment?
Yeah. We can listen, but I don't know why mine I can't.
Oh, okay. You
Yeah,
just
yours
watch lah.
we can.
Okay,
Yeah.
pH sensor experiment. In this experiment, we need to investigate the relationship between different types of fruits and vegetables with pH value. So in this experiment, we will need different types of fruit and vegetables, and the vegetables that are provided is papaya, red guava, and orange. While the apparatus I needed is multimeter, 2-wire, and screwdriver. Before I inserted the screwdriver into the red guava, I already rinsed the screwdriver with clean distilled water to ensure that the screwdriver is clean enough. So after I set up everything, I can conduct my experiment now. So before that, I'll turn on my multimeter to 200K, as you can see here, and I'll insert the wire inside both of these holes. Then I will use the tip to touch my screwdriver here. Then I will wait until the current is steady in the multimeter. So the first value I get for this red guava is 0.5.3. I will repeat it with 3 times to ensure the measurement is accurate enough. Second value I get is 0.5.1. Repeat it again until the current flow is steady in the multimeter. So for the third value of my red guava is 0.5.4. Then we switch it to second fruits. The second fruits for me is orange. I will rinse it with clean distilled water. Use a clean tissue to wipe it. Then I will insert the screwdriver into the orange. Then I will start to conduct my experiment again. I'll use the tip to touch my screwdriver. Wait until the current flow is steady enough. Okay, so for the first value, I get 0.2.4. I'll repeat the experiment again. Touch the tip on the screwdriver and wait until a steady amount is appear on the multimeter. Okay, the second value I get is 0.2.8. For the third value, I'll repeat it again. Okay, so for the third value is 0.2.7. Okay, then I will pull the screwdriver out, rinse it with clean distilled water again. Wipe it with clean tissue. After that, I will insert the screwdriver into the papaya. Okay. Repeat the procedure again. Insert the tip on the screwdriver until there's a steady current flow in the multimeter. So the first value I get is the first value I get from the papaya experiment is 0.2.0. Repeat the experiment again. Touch the tip with the screwdriver on the screwdriver, and value is 1.9. I'll repeat the experiment again. Touch the tip on the screwdriver, wait until there's a steady current flow in the multimeter. The third value I get is 02.2. Okay, so that's the video lah for me. Then for the result, I actually made a table if you guys want to refer it. So the value that measure is current. From the video I show is 200k. No current, resistance is resistant. So like this is the table I tabulate after my experiment lah. You guys have any problem? No?
Oh,
No.
I open. Yeah, so basically that's my experiment. It actually take me a long time, but I also trim it become a short video.
You know, initially I thought your 02.4 and 0 something something. I thought it's 0.24, you know, but after you show the result of this table, I understood.
Sorry.
Yeah, it's okay, it's okay.
Maybe I speak wrong in the video. Yeah. So
It's okay.
that's my presentation lah. How to off? Okay.
Yeah, you off.
Okay, I off already.
Yeah, you off it already. So Santos, are you okay already?
oh yes.
Or it's still lagging?
No.
So you can share it already.
Yes. Can you see my screen?
No.
No.
What?
Oh yeah.
Okay.
Yeah.
So,
Are you using your phone? No, right?
I'm using both actually.
Okay.
Okay, so for the apparatus I'm going to be using the multimeter and screws and the lime, strawberry, and tomato. So for the first one, which is lime, I measured until, sorry, that's lime, not lemon. Okay, I measured the first value. Actually, I cut out the first and the second values. I didn't know we have to record it. The third value was 10.4. Sorry, no, not 10.4. 8.4. Yes. But the first and the second values are, the first is 8.5 and the second is a 7.8. For tomato, the first value was 3.2. The second value was negative 3.2. The second value is negative 2.8. Oh, actually, this is the first try. Yes, here I'm getting a negative value. And the third value was 3, stable 3. Around 3, negative 3, sorry. And then for strawberry, the first value I got was 10.7. The second value was 10.1, and the third value was 10.4. That's all.
Saunders, are you using current?
No, I'm using resistance.
But you came out with a negative value, is it?
Yes, which is, I don't know why, but I tried several times. I get a negative value.
For strawberry, is it?
So for your tomato, you get negative value, right? For 3 of them.
Yes.
May I double confirm back that your strawberry for the first reading it's 7.7?
Strawberry 10.7.
Or 10.7. Okay. So actually we all have weird result. to be honest, because in this result, we should expect like, because the more acidic it is, the current should be higher and the resistance should be lower, because current was inversely proportional to resistance. But all our results were a little bit weird. Yeah. So I think that's all for our presentation. You guys have no question for Sandos?
No.
Okay, so this is the end of our group presentation. So now we are going to discuss about it. This is not part of our discussion. We are going to discuss whose result to use in our part 1 and part 2. Is this okay?
Yes.
So we all agree to choose
The
some
best
result.
fit.
Yeah.
Yes.
So for Sondo's part 1, you are using cola. Let's start with me first, because I do the experiment first. So I'm using the 5 household chemical, which is my hand sanitizer cannot use, it's out, and glue also cannot, because glue was actually have alkaline properties, and vanilla extract, if you guys want to use, you may use. Wet tissue and vitamin. So you guys agree to take vitamin, because vitamin was actually, yeah. So let's take my this one, jot down, yeah, everyone. The water soluble vitamin, it's pH 5. So next, it's Hafiz. Hafiz did toothpaste, vinegar, and hair gel, and shampoo. So do you guys okay if we take toothpaste and vinegar?
Yes.
Yeah.
Because the value was nice. Yeah, it's like extreme value, so
The
the
pH,
contrast was there.
the pH for toothpaste is 13, right?
No, 11.
Not 11, sorry.
Am I right, Hafi? Right,
Yes.
Gan? Yeah. So the
Vinegar
toothpaste, pH for toothpaste was 11 and vinegar is 1.
is 1, okay.
Yeah. So proceed to Sondos. Sondos use cola, floor cleaner, rosy water. Is it? Am I correct? Okay. And Clorox. So what do you guys want to choose?
Coca-Cola.
Coca-Cola. Okay, let's take Coca-Cola. And the Coca-Cola was pH 2.
Yes.
Correct me if I'm wrong, yeah? And for Kelly's, she has detergent, soy sauce. Oh my god, what's IP? Perfume.
Insecticide and local.
Yeah. So, what do you guys want to use? Is it okay if we use detergent?
Okay.
Do you guys agree?
Yeah.
Yeah. Detergent.
pH.
So the household chemical that we used for our lab report is, I'm going with increasing order, yeah. Vinegar with pH 1 from Hafiz. Coca-Cola, Coke, pH 2, Sondos. And water-soluble vitamin, pH 5 from me, from Audrey. And then detergent,
pH.
pH.
What's my detergent? pH
Your
9.
Just now in the video you said it as pH 8 to 9, so we can't. So do you want to fix it?
Yeah, I think I fixed it. Wait, yeah, that's my result. wait, let me find my result first.
And from this we can say that this is one of the limitation of universal paper. It's included in our discussion later on, so we can say this in our discussion later on. So the detergent was 8 or 9?
pH 8 is nearly to 8. So I feel
Oh,
we can it is pH 8 lah.
Okay, so the detergent was pH 8. And lastly, toothpaste from Hafi is pH 11. So that's our conclusion for our part 1. And our part 2, it's a bit weird. All of our result was a bit weird, but we should take 3 of them.
Three?
We all are using 3. Since we are asked to, 3. What do you guys suggest? Since Hafi do current. Current was not wrong actually, Hafi. No need to worry. Because later on we can discuss this on our discussion later on, and we can explain to doctor that why we use current or why we use resistance. Like how can we connect this?
Yeah, agree.
So any suggestion on our part 2?
I feel my reading is quite okay if you guys want to use.
Yeah. So do you guys agree with using Kelly's reading?
Yes.
Because Sondo's, I'm sorry, but
Yeah,
like
I know.
mine, like mine also have some weakness. Hafi actually we can use, but it's not that accurate because he's using current and supposed to be mango, and the pomegranate has a higher value. So okay with using Kelly's?
Yes.
Hafi okay? Are you disappointed? No, right? Like it's not we don't want to use. If you want to use your own one, it's actually also okay if you want. But then I suggest we use one result only so that we can have
how to say a more accurate result and a more discussion.
Yeah. Okay, so for the part 2, Kelly, you want to conclude it or still me conclude?
Okay. Then I think I share my screen now, that you guys see my result. So this is the result I get for my part 2 experiment. Yeah. Shall we discuss it on our discussion part or here?
Discussion we just discuss without sharing screen. Yeah.
So for
So
this one, So for the discussion, so for the result for my experiment is like this. I measure it with resistance. So the resistance for red guava, I think the average reading, so it's 5.3, 2.6, and 2.0.
Okay. So do you want to end this? I mean by whoever want to end this presentation for the doctor or I end, or do you guys want to end? Like, okay. Okay lah, I end. So this is all for our part 1 and part 2 experiment. And for the part 3, we are going to do the discussion in our discussion later on. So this is all for our group 7 presentation. Thank you. Okay, let's all say bye to doctor. Bye, doctor. Okay.
Thank you, doctor.
So we can stop recording. Who is the one who record?
Me.
May I ask?
Me.
Okay.
I think we need to end this week. This
Yeah.
only we. Yeah, we need to leave this meeting.
No, you can stop the recording and we should leave.
Okay. Oh, okay. I found